So now we are going to discuss the same. What is that? You know the what we know, gradient, del, gradient, divergence, and curl. Okay, gradient, you know, del of phi is there, del dot phi is there, and del across phi. These are there. Okay, he may change the notations. This we completed. Or del is operating with the various cases, then we will get the gradient, divergence, and the curl on. Okay, along with the space. Okay, at a particular point on the x, y, z, all we know that. Now the three important cases we are going to discuss. Okay, the different types of integrations. Okay, the different types of integrations means one is linear integration or linear integral, or second one surface, and third one is volume. We are discussing today volume, linear integration, surface integration, volume integration. Linear nothing but line integration or line integration we are going to discuss. For example, what you know generally, okay, what is the linear line integration? It is a linear integral is an integral of function along a path. Integral function along a path of line. This is called line integral. Deals only with the single variables. Okay, let us will start to take the curve. Okay, one straight line curve of a vector field. For example, if you take one field, this 1 2 3 4, these are the fields. Okay, or we call vector a, vector a, vector a, vector a, vector field, vector field, vector field. Okay, here space it. Okay, or you just draw one curve, closed path. Okay, or you take among these closed path one curve, like this one curve. For example, p and q is the curve. P and q is the curve from p to q, and it start to p and ends at q. Okay, this point. See, you take any one point here. For example, here this vector, any one part of the vector, this point may be made as a m midpoint. Or you draw a tangential for this. You draw the tangential for this tangential is the smallest element of this line. Okay, pq is the one line of integral, but dl is the total, l is the pq is that, dl is the element, small element of the length, dl is. Okay, and making an theta with respect to vector and the element in between the dl and m, one small theta is there. So this we can express in the linear. How? For example, okay, the path pq, okay, is equal to is a integral of p to q, initial to q, a vector into dot dl vector. Okay, this is going to denote or the define as a linear integral or line integral. Okay, nothing is there. Okay, or if you taking the closed path means just you apply the closed circuit p to q, a integral vector b dl vector. So this is the linear integral of 2 points. Okay, the line integral is used to find the potential difference 2 points in the this field. Okay, let's see. Okay, or you take in surface integral, or you say done done these are the same vector, a vector, vectors are the vector. Just close. Okay, this is take one initial element surface. This element surface is ds. Okay, ds. Okay, this is ds, or perpendicular to this n you take. N is the unit vector cap. Okay, from this vector to the normal, this is called the theta. Okay, so what it is representing for the particular surface of this closed surface is known as integral surface. So we considering the same the area of S. Okay, total area, this total area is S. Okay, and small area, this small area is small area ds vector is a, and making an angle ds to the normal, the n is normal, that is called theta, that you know. Okay, Now then the surface integral can be written, okay, surface is indicating like the surface integral, the same thing, vector A into where there in that case element is there, here surface is there, therefore ds. Okay, this is the surface integral definition. Or in the closed path means how will write? Yes, okay, surface is equal to A into ds. This is the surface integral. That's it. Okay, the surface integral is used to find the net electric field through the surface in an electric field. Net electric flux in an electric field you are going to use. Okay, now another one, integral volume. Integral volume, what is that? Integral volume is referred to integrate over the three-dimensional domain, or it is a special case of multiple integral. So for example, this again space is there, so many charges are there, charges. Okay, one midpoint you take, midpoint take, tuck like this is a midpoint. This is the small element, small surface, okay, in all direction, three-dimensional surface dv. Okay, this is a big volume v, small volume, okay, among the faces b. Okay, so v, therefore v is the volume of the distribution or charge of the volume, charge is through the volume, and the continuously and a small value volume, small volume will be dv, and the rho be the density of the charge. Okay, and at midpoint m, okay, density is the charge, v is the full volume, small volume is the dv, what I am considering for the test. Okay, by these how we will write volume integral? The volume integral can be written as, okay, volume integral can be written as, okay, yes, surface through the surface to the density into dv. Okay, charge of density, mass per unit volume of the charges, this will be defined. Okay, so the volume integral, it is used in the three-dimensional formula. So this, in this way we are going to discuss. First remember line integral. Okay, line integral is what? Once again I am line small in a closed path means p to q or whatever ends are there. Okay, then a into dl is there, vector a into dl is there. Then second, surface means closed surface we will write, that is a vector into ds, small element is there, but volume is closed surface into what will it? Density into dv. These are the three different cases we are going to discuss, that is linear, I mean nothing but line, okay, and sorry to say surface, and then another volume. So this will complete the three types of integrations.